Hello, welcome to another video. So this one I wanted to look at a bit more into how I might start assembling some instructions. So this code, this dumping on the left, shows just a couple of bytes at the top, which kind of correspond to these instructions here. So my compiler can only really do this like that, really. Anything with dB or times in it, and it can do some basic arithmetic. But what I thought I might do is kind of work towards the path of printing something on the screen. So if I think I can do this, or so in this we have OS. Can we have another one, OS Phasm, or um, let's do the same there, and then also there. I think it should just magically work to write file, and I open it with view for some reason, because I thought the option would exist, I guess. So if I go OS Phasm, it will compile this file and kind of run it, and you can see it prints out okay. And that's all that I really want to do. Might not even get to it in this episode. So it's got a few kind of tricky points. So what it's doing is it's going to move a few things into some variables, and then run int 010, and that is actually all I need to do. So like if I go like, I wonder if this will get me to a page that I want. I mean, that's kind of, this one was kind of alright. Yeah, this one's kind of. So if we kind of look at in 10, what it's saying is the first in AH, whatever that is, so it's OE, that will correspond to this 10E. And so AH is 0E, and AL is the SE character to write. So what this will do is just write a character that we tell it to do in teletype mode, I guess. And so really all I need to do to add to, so this one, if I go to that, and if I look at mine, really all I need to do, actually what I wanted to do was maybe have that listing, and then here I can open up mine. So instead of doing that, so the use16, I'm going to avoid that for now, because I think with these instructions, I don't need to care about which bit size it is, because I'm using AH and AL, it has to be 8-bit value on the left. That's just what it is. But if I did the JZ, that would probably require some different assembly. So for now, I kind of want a comment operator as well. And like there's a few different ways I could do this. Like what kind of commenting scheme do I want? And like, what scheme does Phasm actually have? Comment. The line contains a semicolon. Yeah, so that's right. This is a comment in Phasm. I potentially could do some research into that, but like, I don't know, like these could be valid comments. But then this one is a bit harder because how do I know if that's a comment or a string? The tokenizer potentially will, that just is the thing. So I think I can't do that. I kind of like one of these bottom two. Just a single character and till the end of the line. And I think probably I'll use the same as Fazin. And guess, comment, and tag. So there's a few different assemblers, I guess. So guess is one using it as like comments just down here, so we can do the block comment. We can this like depends on the family. Golly, so it's sometimes that, it's sometimes that, and it's sometimes that. Craziness. Why would that's nuts to me. So I think I might add in a comment just so I can kind of get some way to comment out code. And I also want to add in the feature to be able to write OE and move AO. And we'll start with that and see if we can kind of assemble that down. So this currently will not assemble, and what we can do is I had this one, yeah. So this will kind of it will seemingly compile. So this it's should clean up test dot bin. That's kind of interesting. I think I know why. So when we get this path, we should probably unlink it like before we like even try and. I feel like we need to do that. So in the I recall in the view I have a write file, this thing here, and I do recall this. I kind of made it so it would create and truncate. So if the file didn't exist, it would create it, otherwise it would truncate it. And I remembered I put this unlink here, which is potentially I want to also do, like, I don't really want to, I kind of want to, can we go to here? Like, I think I want to do this. And like, where were we writing it to? The config output path. Output path. So I think I want to try and remove it to start with, and that could potentially be an indicator of whether I have access to do so. But no, I think I'll do that. And then this sort of thing will now no longer find the binary, it will get removed. But if I kind of do a normal thing, then we will have a file again. So it's just when it can't do it. So because of that, what I might do is bring that back down to a bit better. And I want to, in this file, kind of start making that work. And what I can do is run that test file, which I've already done, and now I can kind of work out what's happening. And straight away, I can kind of see that that identifier thing that I've mentioned a few times is kind of playing up. Yeah, what was I thinking with that? Um, so, um, this also doesn't have that mode on. So what I might do is there is a if false, yeah, and then here I want to change this to yeah, if true. And now if I kind of run the same thing, it will give that same error before, so expected equals and kind of point me to this point, but it will also say this is where you call it from, so I can kind of see where I might need to kind of start doing things. And so what I need to do is find where I get this, and it is here. And so what I want to do is I kind of we took the cup holder with me. Cool. So what I want to do is instead of doing this, I want to first make sure that it is what do we have? We can buy one of chars. I think that's what I want. And so here I can give a series of characters that I would expect it to be, but no, I don't want that. I want by char funk, but really I want just chop left char funk. Does that exist? That does. And now here I can give it a function of is alpha. So I'm going to basically assert that. And does this give me the character back? I wonder. Buff view. So in here, what was the function that we were doing? So in here, this does not give me the function back, but I suppose the returning view does kind of give it to me. So if we kind of go back here, if token dot size, so if we have something, that kind of means that we perhaps have that. And here I probably want to throw an error that we have a unhandled token, I guess. So how do we do that sort of thing? Is it kind of that? Interesting that it took me there. So we get that, and then here we can just have unhandled token. And do I kind of want to say what type of token it is? In which case I need num token. So perhaps just one this, but unreachable. We can just make that unreachable so it won't get past that. And then maybe this unexpected can be unhandled. Perhaps this can even be to do or something, I don't know. But yeah, so now we have a token, which is the start of a identifier, I guess. So we can probably make that token just be that, just so we capture that. And then we want to token equals string view chop left until like can we have uh, so in here we have what did I want? I wanted, I don't know, just take me to this one, I guess. Does the buy one of Char's, that kind of splits it. Doesn't it? I think I kind of want an until but a while. And that way I can have chop left while char funk. Give it the tokenizer and then give it is el num. Is that what it is? And then it will kind of chop me a string based on that. So I guess I need to implement that now. So we can probably just do some replacing of until with while. And we'll also have this one, so maybe we'll do the same for untils. So here I kind of want to search for this string and then go down until we're there and maybe copy that and do that, and we can, oh, that's like, so now we should have two of these. So now if we do this sort of thing, and we can get all of that. And if I do until and while, that kind of does what I want, but I also need to do some things inside of here. And I think that's that. This is a little interesting. So if we have that, we would. Oh no, we just want to do size there. So we can just size plus equals, and this will be str.size. So we can just skip the thing if it if the CMP returns non-zero, which basically means it differs in some way. And if it differs, what do we want to return? We kind of want to return the string up until now. And we also, if we don't want to chop the string, oh, not yet. So we will still want to do that. Cool. And then in this one, we probably just want to do a similar thing here. And then we can just size plus equals his size, I guess. Do we just have a str size? We skip over that. Otherwise, we do that. And this one, so while we have the character, so I probably just want to do that, and we can just skip by one. While one of characters, we can probably just do that and one is fine. While character function, we can probably just negate that, and one increment is fine. And while string view function, what we probably want to do is um, I think I want to do a different thing. So if we uh, haven't chopped anything off, then we should return. But if we have, which yeah, then we just want to do size plus equals chopped, I think. So if it was 0 here, then this not would make it a 1. See, yeah, But yeah, if it's a 1, then it'll make it 0. Either, so that would be that, and then now we want to maybe go here and then search for the right ones. Few less of them. Is that it? That's it. So then we get that. Now we should have few of them. We'll get this last one. We'll do that replace, and then here. So no, take me to this one. So now we should only have one of these. So here, if we have that, otherwise size plus equals what's the r dot size, and here we just want to negate that, and then size plus equals str size, and while char we want to find that equals and negate that, and then one's fine. Here we just want to go not found, one's fine. And while char func we just want to negate that, and one is fine. And we don't have a string view because it doesn't really make sense there. So I think now we have this function here, which I'm somewhat comfortable with. And so now we can go plan.size plus equal token.size, and that will get us the full length of the identifier. And so we need to make a string view, I guess. Is that what it is saying? And we can just give that string view instead. Then we kind of need to allocate that, all right, and then we would do that instead of this, and then basically none of this would happen. And I think this will break some tests now. So perhaps I even want to go back to that and kind of deal with that. So Token.type doesn't exist, but we can just say unhandled token. We don't kind of know what it is, but perhaps going to it. So print it out and unhandled token, and perhaps here we can string view format, and we can just kind of print out the token that we have with string view args of token, and so we don't actually have a token type. And then when do we return the EOF? Do we return it any other places? Yes, so we if tokenizer dot size, that kind of means that we have stuff, and if we don't, then we would return that. So we are a pointer, and yeah, so that did fail with a few things. Few things. All right. Right. Maybe I will look at that a bit more. So I think it was complaining just on that sort of thing. We got the wrong scope. So if we go back to here, I think we need to go token equals span. Perhaps here we can token equals span. And then here we can change that back to token, and then here we don't need to set it, and that's good because it also has it there. How does that change things? So now it gets the full scope of ABC1, and I feel like that just fixed all of the issues. Cool. I thought that would have complained about percent. Do I not have a test for that? So if I go times 3 dB percent, and we can add in a debug flag, and it does seem to work. Did I particularly make it that? It's kind of interesting. How did it parse this? So it did get it as an identifier. That is interesting that it gets past this is alpha. So if I learn how to navigate a bit more, is alpha, I would not have expected yeah, I wouldn't have expected any printable character which is not a space or alphanumeric, or potentially I get that. Spaces should have been caught earlier, so I can't do like not. Here is alpha of that equals that. So I am curious of is alpha of that, and here we don't know. We need another thing there. Can we do it in this? It never once did it, but can we grep for is alpha? Can we do that sort of grep? So that never actually fires off. So where else do we kind of set this identifier token? Free token. So we do check for that, and I was searching for the wrong thing. Yeah, I was searching for it in double quotes, but if I searched single quotes, it would have been better. So we do specifically kind of call that out there. That's good. And we could do more stuff there, but that's all good. So that means that I want to find the other one that we were testing, just my thing. So there's still more stuff to do. So now that is what I want, an unhandled token on that. So that means that this is where we're wanting to do things, and what we're wanting to do is basically get one of these, and we can change that and semicolon, I guess, and that means we'll need to kind of make a semicolon. I wonder if I wanted like that. And this is potentially yeah, so like this just kind of like magically works. So what I kind of want to do is where we do a switch on a token, I want to do a static. First off, we need to include what am I thinking is cert diet, so we can get that, and then we want to static cert num tokens equals blah. We'll start with 0. And is this, it takes a thing, one, no. If yeah, we can provide a message afterwards. And can possible unhandled token type, and we can just have something like that. And so now if I have a look at where num tokens is, do we not have num? Oh, we have ASM num tokens. Okay, num tokens, ASM num tokens. So if we look at where this is, it is basically the end of this list will get added on. So we can see here we've got what, that's 19 tokens. So we can probably change this to 19, and I kind of want this type of switch to happen for every type of thing. So we probably also have another like place we do a token, so we can do that, and we can do that, and do that. And this is computed expressions as expression. That's pretty, and I'm making a bet that it is the right one. So now if we kind of go to the next one, I kind of want to do this, but num expressions equals that, and if we find that, we can go expression. And if we look at this, so now it kind of straight away complains about this. We have a look, we have 10. So we go here, we can change it to 10. So now if we search for that switch again, and we're looking for expressions, just expressions, expressions. And the idea is it will now tell me where I need to kind of add all the things that I need to edit. This is computed. And potentially none is the answer. Expression 2, I've already got one there. So now if I compile it, complain there. So I have like other places, but that's like a runtime failure, and that means that we were not well, we were checking on the num tokens, but the problem is that I added a token type, so if I kind of remove that, then all of those static assertions would fail, which when I in fact, I kind of want this to not that. If I search for that and change it to 18, and then and do something like that, and do that everywhere, then what I can do is at the bottom here, I can add in that token, and now the compiler won't let me do anything until I'm like certain that I have handled that token. So I have just added what token was it? It was a semicolon. So when I hit a semicolon, I don't have to do anything extra for pre-token. When I am parsing an expression, I do actually want to do something different for a semicolon. I want to kind of ignore everything until the end of the line, which kind of means that the white space needs to track a new line. Yeah, because then I can do a thing like that. So I think I'll leave it at 18 there, but I'll move on to the next one. So this is if I'm looking for a plus or a minus. And I think here I will also kind of leave it and deal with it later. Here I think I'm happy to increment this particular one. In fact, yeah, because this is we're already in this thing, so we should only have these two. But this outer one, if we had a comment, then we kind of want to deal with it and parse to the end of the line. And yeah, I think that's all good. So this one we're parsing, yeah. So I kind of want to keep those two the same. And this one is when we get a comma. So in there, I kind of want to leave that. If we get Um, it- I mean, almost in this, I almost don't want to have it in the token stream. So if we find it, we just that token doesn't exist, and up until the next new line doesn't exist. Or I can add it just as a comment token. Yeah, I might do that. So um, we have a semicolon, but what if I do a comment token and it can perhaps go up into one of these type things? I don't know. Maybe where it was is good, but we can comment, and here I want to do a different thing to that. I can probably go down here, perhaps, yeah, perhaps like at this point here, we can token equals string view chop with the character, and if we give our tokenizer and we give that semicolon. So here we can check if token dot size. If we have a token, then we're going to return a thing bob. So at this point here, we might want to do a string of ut span equals token. Perhaps the we could call this rest actually, a string of u chop left by one of Charles. There's not much difference between the by and the until, apart from it. We don't care about it. Apart from the fact that it splits on that new line. But yeah, so what we can do is do that, and so if we so then we can just token dot size plus equal rest dot size, and here we can potentially just return token comment. Is that all I really need to do? We don't really need to allocate stuff, so we don't need a literal. The literal is just the span, which kind of comes with it. So here, when we are parsing an expression, if we reach a comment, we probably just want to skip it, right? So token comment, maybe something like that. So they'll kind of skip the comments as well, in which case I don't need to handle it there. And this should probably also have it, or token dot type equals ASM token comment. We shall do that and do that, and here we also have a similar thing. What token dot type equals ASM token comment, and I kind of want to so what about this one? We are parsing a statement. This also has a token dot type equals ASM token comment. And here, what do we want to do? That's just the one that we did it. And like that's that. So it's moved on. And expecting equals. So it has gotten that as an identifier, I guess. And we can see what that is if we kind of do a debug flag to my thing, and it will say how it reads every token. And so we can see here that it got AH as an identifier, then it got a comma, which is probably what I would expect. After identifier move. So, oh, right. So it's put me here because it's seen in AH, but move isn't a thing. So it successfully skipped over the comment. So what I think I might do is add that up. That's a different thing. We'll do that. 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 And that check string and return. So if we go here, check string and return. This was not meant to come up, but we can add it back in. Right, so this, we're changing that, and then we bring that back in, and so now we handle that. We'll do that as well, we'll do that as well, we'll do that as well. Cool. And we can add beam again because we may as well just do that. Add comment. Cool, and then we can do that, and perhaps we can add in some stuff for like multi-line comments, or we can just have a single line comment on every single thing. So what I think I want to do is also do that same thing for computed expressions. So if we look for this, I basically want every time we have a thing where it's a computed expression, like here, we now want to check for computed expressions and computed expression type. And this one's a particular different one. And then if we have a look, there's only 4 of them. So we can do that sort of thing. But I do want to search for that switch again to find any more computed expressions like here, and just get a normal one without the backslash. That one, that was a unary. And so this just kind of helps catch things before they become issues. So here we also have statements. So we have 5 statements, and if we do that, we can look for a statement. Oh, that one had a computed type that didn't have a thing. Let me find like that useful one. So here we had a computed expression. Makes me wonder whether we had any others that I missed. I do kind of tend to jump around a bit, but that's just how it goes. So I think statements is what I want now. So there was, what, 5 of them, was it? So we find that, and number of statements is 5, and do that sort of thing. And now we kind of have a search for that. We can probably narrow it down, to be honest, to be just statement that we look for. Um, I don't know why I copied it again, but that is what it is. I think I want unary now, or binary, I guess. I could probably do both, to be honest. So we can have that and then ops. So I think I just had two binary operator type. I think I just had those two. And I think I just had the one unary operator types, but we can have a little look through to see what we're missing. We're missing something on binop. So here we can then ops, and there was two, and binary operator. Also missing that unaries, and we know do that, and then unary operator. And we should now have everything. Like, that's just characters. It's always going to be 255 of them, and tokens, everything. And so this should be quite nice, I think. Cool. I might commit that. I'll make sure it builds, actually. So it doesn't. It reckons we have more than two, I guess. We have a none as well. So yeah, that's just going to have none added to all of these. So there were just a couple. There's one more. One more. So we can probably add up all of these. Easy. And static is on stuff. Cool. So now we are at the point that we do that. Is not really knowing what a move is. So what I can do is kind of what time do we yeah, so what I might do is do this, and we can have a token of MOV, and that token is going to be a statement as well. And it's going to be a MOV statement. Yeah, I think that's what I want. And I think I've just decided that I don't want commas to be part of the expression, because here MOV also has a comma in it, but I don't want it to be bundled up, because I will also have a new thing that needed soon. So if we have a MOV token, I think that doesn't have a literal. That yeah, it won't take a literal. When we will leave that until we kind of define what a MOV thing is. If we are parsing an expression and we get a MOV, we shouldn't get one, so we'll just let this default one kind of catch it. If we so this is still where, like, parsing an expression. Where was it? Here we also don't really want a MOV, so we'll just have that default, which will roll back. I think that's what I want. because yeah, then it will get the mob as the next thing. So here we shouldn't have anything here. This one is a case of it will probably never really need much adding, but when we have the bin ops, that's kind of when we kind of need it. And I wonder if I want to have bin ops, and we had what, three bin binary operator types, and then like we'll kind of know where to add it. It does add like a bit of extra churn going into things, but it, perhaps all that. And unary doesn't really make sense to it there because like we only really have it in the one, but cool. Where's the next thing? Statement we're waiting on. This we parsing a DB. I wouldn't expect to see a what is it, mov in the middle of a DB, and if I did, then it would be a token error. Though I guess in theory, oh no, it's now a keyword. You can't. I was thinking you could have something like mov equals 3, and then mov mov, and then it will move 3 into but then like I don't know, that's a bit too weird. Right, so right, redo a few things up to that point. I think is good. Come on, this keyboard's doing weird things recently. Right, so this is when we're parsing a statement. So this is where we might need to kind of do things. And I wonder whether I have statements, and how do we do that? It's 5. And because the output of this is kind of what it will be, and we will be doing a thing here. So we'll have a case ASM token, and what was it? And we have that, and if that is the case, what we might do is steal one of these ones, and we can kind of just do the same thing as for example. But here we will probably pass a mov. I don't know if this is the best way to do it, but it's the way that I'm doing it. And so here we return that, otherwise we're going to return a mov, the statement. And we can just store all the information in that int pointer. And this path mov is going to do the heavy lifting. So if we have a path mov, I guess we could deal with this here. We have a path mov, and I think if we have a statement literal, we should do an ASM pre mov on a ASM mov t pointer to that statement literal. So it's quite similar to the other ones, which makes me wonder if I can macro that up a little bit. And that means I've now handled that. This function doesn't exist yet, and that type doesn't exist yet, and that type doesn't exist. What was I complaining about? It's just because the type doesn't exist. That's all good. And I believe we kind of handled that token by doing it there. And so now we don't have that type, we don't have that function, and here we had a typo that should be mov. And here we also don't know what to do for executing. Where do we get to? Where we make it times t. I think I want to just make a mov t. And so this is kind of where you start to think, what do I actually need out of this? And yeah, it's kind of interesting. Yeah. Kind of interesting because what might you need in a move thing? So I believe you always kind of need some kind of left hand side, which is going to be the target, and then some kind of right hand side, which is going to be the expression that you are putting into that thing. And like it kind of depends what is happening on each side, what's what. And I wonder because we almost need this kind of handles registers and also thing, but this particular one is the one that I want. Maybe bump that up. This particular line is really all I need to do to if we source boot x86 BIOS mine to do this move AH. So the AH is a 8-bit register, and the IM8 is an 8-bit immediate. So I guess what that means is we kind of need to be able to parse whether something is a register or not or something. And I kind of it's kind of interesting because you can also have like registers on the right, which yeah, it's I've started with a hard one, but perhaps just getting this first one going because all we really need to do is be able to parse whether something's a register or not. And at the time we have it, we see it as an identifier, which is potentially good because with that identifier, you can use it as yeah, it's kind of interesting. But I think what I want to do is in here, I just want to have an expression for the dest and an expression for the source, destination. And that's the two things that I want in a mov. And so we'll have a 3 times, I guess. And so if we kind of make that what we call this a free mov, and then we can call this a mov key and then a mov, and this is a mov, and then we can just free expression twice, and it's going to be on mov, and it's going to be on what we call it, the destination and also the source, and we can kind of do the rest of that stuff there. And that's all we need to do for free-mov. And you can see here these errors are getting smaller and smaller. So we don't have parse mov yet. We can do that not too hard. And yeah, because we don't have the function that complains, and here we're saying we don't know how to handle it. What I think I might do is perhaps leave it at that. And it's kind of at the state where it's not really compilable at the moment. So I might actually switch to a new thing and add mod, and then we can kind of add in something that doesn't quite isn't quite complete. So work in progress, add mod, and I think I'm going to leave that there because there's a few more fiddly things to do. For now, thanks for watching, and I'll see you next time.